Hello and welcome to the sixth video in our lecture on biometric and token-based authentication. So in the previous video, we discussed smart cards, and in this video, we want to step back a little bit and talk about smart tokens in general. So the setup is that the user is trying to authenticate himself or herself to a computer system, and then the user owns a smart token, which by definition is a token that contains an embedded microprocessor. So the way the user and the tokens are going to authenticate themselves to the computer system is by running an authentication protocol. And we're going to classify these protocols into three rough categories. The first category is the static protocol. So this is a situation, a protocol that takes two steps, where first the user is authenticating himself or herself to the smart token, for example, using a PIN. And then in the second step, the smart token is going to do all the work and communicate with the computer system and complete the authentication protocol without intervention from the user. And so the second half of this static protocol is very similar to what happens when you're using a non-smart or just a memory token. The second category of authentication protocols used by smart tokens is a dynamically generated password. So in this case, the token is constantly generating unique passwords every so often, say every 5 minutes or every minute. And so this password is presented to the user, and then the user can enter this password into the computer system, either manually or tells the smart token to send that password automatically to the computer system. Now, for this to work, obviously the smart token and the computer system must be fully synchronized, since for the computer system to check the password, it must know what the current password is, and this password changes over time, so synchronization is crucial. And the third category of authentication protocol we're going to talk about is the so-called challenge response protocol. And the reason for this name is because the first step is that the computer system is going to generate a challenge for the user. This challenge will typically take the form of a random number. And then the user is going to use the smart token to generate a response that will be based on this challenge, and then providing that response back to the computer system to authenticate himself or herself. So the important aspect in this kind of protocols is that the challenge and response are basically two numbers that are linked to each other. And the way the user authenticate themselves is by proving that they are the person they are. And they do that by taking the challenge as input and somehow using it together with some of their identification information to produce a response that they can then submit to the computer system. So let's look a little bit more detail as such protocol. In fact, the protocol I'm describing here is kind of a mix of the three types of protocols I just discussed. It's going to use a challenge response mechanism. So that's really the main classification for this protocol. But it will also use a password generator, although it will not be fully dynamic. And it will also use static information that the user is going to introduce or input into the smart token. So it's kind of a combination of the three types of protocols. So here is the way it works. Remember, we're focusing here on user authentication, which is the second step of access control. The first step is the identification step, and this is shown here as step 0, where the user, we assume it's a buyer that's communicating with a seller and wants to authenticate themselves to the seller. So first they perform identification by sending to the seller their ID. This is their claimed ID. And the rest of the protocol is to authenticate the buyer. So to convince the seller that the buyer is who they say they are. So here is the first step in this protocol. The seller, after receiving the identification information from their client, their customer, is going to generate a random number, R. This random number is going to be received by the buyer and is going to be forwarded to the smart token. So let's say this is the smart token that uses a password generator. And in addition to the randomly generated number, the buyer is going to send a static item, namely their PIN number. So they're going to input both of those pieces information to the smart token. The smart token in this case is going to use these two pieces of information to generate a random password. And the way they do that is going to be by using a hash function in this particular case. So once the user has been authenticated to the smart token, this processor is going to take as input the random number that was obtained from the seller and a secret key K, and these two pieces of information are going to be fed to a hash function. So the output of this third step is a hash code that the smart token communicates somehow to the buyer. And finally, the buyer is going to just forward this uh, response. So this is the response part to the challenge R. It will send this response back to the seller, and then the seller will be able to authenticate the user because the seller knows both the random number since they generated it, and they also know the secret key that the smart token contains. So this is a shared key between the smart token and the seller. And so the seller is going to be able to hash both the random number and the hash key, or the private key, and then compare the generated hash code to the one it receives from the buyer. So this is how this particular protocol works, and this is how the buyer authenticates himself or herself to the seller. So notice this uses kind of a symmetric key, since there is a key that has to be built into the smart token that is shared with only the seller. But notice also that the buyer is authenticating himself or herself to the smart token using a static item like the PIN. So this is a typical challenge response protocol. This is just a generic description of it. If you want to see a particular example, I strongly recommend you watch this 2-minute video on YouTube that was produced by a company called Advanced Card Systems. And so they actually demonstrate how this mechanism works. Notice that, again, this is not quite the same as a dynamic password generator, because in this case, the password is not generated automatically at regular time intervals. Notice in this case, the password is generated only when the user needs it by providing a PIN and a challenge random number. But still, in this video, you will see a full demonstration of such a protocol. And in this case, the application is not someone buying an item from a store, but it's a customer of a banking system, and the customer is trying to do a transfer of funds from, say, their checking account to their savings account within the same bank. So this is an intra-bank transaction using a challenge response protocol to perform user authentication. So after you watch this video, make sure you watch the last video in this lecture when uh, we will be wrapping up the lecture talking about two-factor authentication.